Okay. So what kind of triangle is this, guys? Isosceles. Thank you, Griffin. So it's an isosceles triangle. So this tells me that AB is congruent to BC. The markings are a big giveaway, right? If that happens, we also know that the opposite angles are congruent. The angles opposite to those sides. What angles are opposite to those sides? Angle A and angle C. Yep. So angle A is congruent to angle C. So we know that as well. Okay. Another thing that we could probably say is that these are probably the same as well. So it looks like that's going to be an angle bisector. Let's say I call this D. BD, line BD, bisects angle ABC. That's always true because of the symmetry, right? Because of the line symmetry, we know this. So that also tells me what else is going to be the same. Angle ABD is the same as which other angle? Be the same as CBD. So this is cutting ABC in half. So we got all these different relationships happening. We're in a sausage triangle. And remember, the word congruent is a word that we like to use often when some geometric figure or representation has the same size and shape. So when the angles are the same, the sides are the same, we use the word congruent. You could also use measure if you wanted to put like the measure of angle A equals the measure of angle C, but then you don't put the congruent symbol, you just get rid of it and say it equals. If you want to do it that way, you could do that also. But if we're saying like, hey, this entire thing is the same as this entire thing, then we just write like that. Okay, so that's just kind of get started. Now, next up, let's kind of go around the room and answer these questions. Okay, so Emily, can you read 225, please?
Examine the following parallel lines cut by a transversal. Determine if the following angle pairs are congruent or supplementary. Be ready to justify your answer.
Okay, cool. Now, remember we did that activity the other day with the tracing paper? We drew this angle. And remember we slid the angle up? And we slid up, for those who are not here, you didn't do this, but when we slid the angle up, we notice it's the same as this, right? And what do we call this relationship between these two? Start with the C. Well, they are congruent. That's what they add up to 90. Corresponding. It's okay. You see why we call them corresponding? Because they correspond to each other. They're in the same position. So if you drew this on tracing paper and slid it up, this angle corresponds to that. And corresponding angles are congruent. That's good. But why? Because they correspond for parallel lines. So remember, corresponding angles for parallel lines are congruent. That's from the last lesson. And sorry, my handwriting looks terrible there. Corresponding angles for parallel lines are congruent. So then if you look at B and C, now that B could be up here as well, how are A and B related at this juncture? What do you think? They're vertical. They're opposite each other.
The same.
They're the same. Thank you. Okay, they're the same. So in this case, I know that angle A is congruent with angle B. So we would say they're congruent. No, terrible handwriting. Angle A is congruent to angle B.
For corresponding angles.
For parallel lines. Yeah, that's a symbol for parallel. When you have two little like vertical lines like that, that stands for parallel, right? Now let's take a look at these two here. Do those look like they have the same measure? Like angle A looks less than 90. Does angle B look less or greater than 90? Looks greater. I mean, we don't go based off looks, but in this case, I think it's safe we can do that. Here's angle A, here's angle B. So it's probably not the same. Now, if I were to slide, if I took tracing paper, right? If I took tracing paper and traced this angle and slid it up, and let me get rid of this because this is now getting to be a little distracting. Okay, so angle B is right here. Excuse me. So if I slid it up, it goes there. Now, if you think about it, these two are side by side as part of a line, straight angle. What's the measure of a straight angle? 1/8. And these are both part of that straight angle. So what would they add up to? 1/8. And what do we call that when it adds up to 1/8? Supplementary. Complementary adds up to 90, but supple adds up to 180. So I'm gonna call it supplementary. So angle A plus angle B equals 180. So I'm going to erase this as well, just so it's not as distracting. Those are supplementary. Now, in this case, again, I could use some tracing paper here. What if I trace this angle and slid it down? If I trace angle A and slid it down, oh, sorry, my apologies. I slid it too far. That was crazy. My apologies. If I slid angle A down, it'd be right here. Those are corresponding. That was crazy. I just didn't really. So that's angle A. If I slid it down, it'd be right here. Okay. How are these related? Just like in the first set, the vertical is still, right? Just like the first diagram. So they're going to be congruent as well. There's also congruence. So angle A equals angle B. And lastly, if I do vertical angles, or if I just slid this down and put it right here, how are A and B related in this case for last diagram? Supplementary again. Thank you, Griffin. Now, there's actually some more terms that we're going to add to this that are actually pretty important that we need to have this discussion. When this happens, when A and B are on opposite sides, you would agree these are on opposite sides, right? Of this line that goes to the middle. And they're both inside the parallel line. So think of this like a sandwich, right? Here's the bottom bun, the top bun, and you're inside the sandwich, right? So they're inside. And they're opposite sides of this other line here, right? When that happens, the name should hopefully be intuitive. It's called alternates. We're going to talk about that in just a moment. Alternates. I'm just going to type this up. Here we go. Alternate interior angles. Do you guys see why we call it that? Because they alternate and they're inside, right? So then the next one, again, they're both inside. So it's kind of things like the bottom bun, the top bun, right? They're both inside, but on the same side of that transversal, that line that cuts the parallel lines, the line that cuts through them. We're going to call that same side interior angles because they're on the same side. And those out to 180, as you see. The last one I'm not going to worry about. That's just a weird situation. I'm not going to categorize the last one, but the third one I'm going to categorize. So notice that these are on the outside, right? So again, this is the bottom bun, the top bun if you have to think about a hamburger, right? So that's outside, and they're on opposite sides. So anyone want to take stabs at what we would call this, given the other names I've used so far? It's outside.
Sides, interiors.
Yeah, alternate exterior. Yes, good. You can say opposite. Alternate is probably a little better. Yeah, alternate exterior angles. Good. So it's very intuitive. So guess what? Alternate interior angles for parallel lines are the same. Alternate interior angles for parallel lines are the same. But same side interior angles out to 180. So that's what's happening there. And the last one, don't worry. I don't know how to categorize that last one. It's kind of weird. Okay, so kind of just, I'm not gonna move the screen. Look at this one here. So, Ed, you want to read 226, please?
Yeah, yeah.
Love to hear your voice.
The shaded angles shown to the right are called alternate interior angles. They're called alternate because they're on the opposite side of the transverse,
Mhm.
and interior because they're both inside.
Yes,
As between parallel lines.
great. So right now, what do I see? I see angle BCF. Angle BCF is going to be congruent to angle CFG. See how it's marked? BCF, CFG, those are marked. Those are alternate triangles. Those are going to be the same. So when this happens, we can write a theorem or a conjecture or a statement or hypothetical, conditional, whatever you want to call it. If the lines are parallel, which they are, because right now I know that BD, you're told BD is parallel. I need to move this, I need a little more space. Let's move it right there. So BD, excuse me, is parallel to which other line? What do we call the line right below it? You can call it, just give me 2 points, EG. That could work, right? When that happens, when these are parallel, the alternate interior angles like BCF and CFG have to be the same. So if lines are parallel, alternate interior angles are congruent. We use that little symbol for congruent. Okay, let's keep on moving. Okay, so now in these expressions, right? So Natalie, can you read part C, please?
Okay, sorry.
In the right place, yeah, right top of the page.
Instead of writing conditional statements, Roxy likes to write arrow diagrams
Mhm.
to express her conjectures. She expresses the conjecture from part B as lines parallel, alternate interior angles are congruent.
Yeah, so or instead of writing all the words out, you can use symbols. Those two vertical lines mean parallel, lines, arrow, alt, short for alternate, int, short for interior, the little symbols and angle, and then the congruent, the equal to tilde sign means congruent. So you can, we're lazy as mathematicians, we like to do that. So if we look at part D, we accept that vertical angles are congruent, corresponding angles are congruent. We accept that now for part D. So let's formally prove this statement up above. Let's prove it. Now this diagram, I'm not sure why it's there. That's kind of confusing. I'm going to recreate the diagram on the previous page and show you how to write a proof. So I'm recreating the diagram from the previous page. If you want to, you can, or you could just, just kind of flip back and forth. So remember we have BD parallel to EG. We know this. That's an E, that's a G. Here's an F. Here's a C. Remember CF went through both lines. We'll do a red line for that. And we want to prove this. We're going to prove that. So here's how you're going to write this. So we're actually doing our first proof. It's pretty neat. There's going to be 4 steps. Sometimes they have more, they have fewer, it just depends. Okay, you always state your given information. So what are we told? What are we given? We're told that BD is parallel to EG. So we write given. Our job is to prove the last step. We want to prove that angle BCF is congruent to angle CFG. Okay, before we do that, I mean, now we know, but let's take other information before I told you this is true. Before I tell you, probably didn't know this is true. But what did we know was true? I did know that this angle, CFG, the same as this angle up here, right? Oh, I need to add another thought. I just realized that. I need to add a point A up here. Just realize that. Point A and point H. Okay. So I do know that this had to be the same as this. So angle ACD was the same as angle CFG. That's because corresponding angles for parallel lines are congruent. Corresponding angles for parallel lines are congruent. That's why I could shorthand notation that. Right? We talked about that. This angle right here, that CFG, that up there is ACD. Those have to be the same, the corresponding angles. Now, what other angle is going to be the same as ACD? That we need to that we're interested in looking at. Remember, we're looking at BCF at the end. How's angle ACD related to BCF?
They're the same.
They're the same again. Thank you, Emily. Yeah, they're the same. And what reason do I say that? For what reason? How are they related? ACD and BCF, they're the same, but what was the categorization we used for that? When a drug opposite of each other, what do we call that? You guys remember? Vertical. Yeah, there we go. Thank you, Braden. Vertical angles congruent. So that's a logical flow. Like, oh, okay. CFG, ACD is same. They're corresponding angles for parallel lines. Cool. ACD, BCF, sorry, yeah, ACD, BCF. Okay, vertical angles. So naturally, if these two different angles are equal to the same angle, wouldn't these two also be the same? They have to be, right? And when that happens, we can call it substitution, or we call this a transitive property. What that means is that if one thing equals this, and if A equals B and B equals C, then A equals C. That's what it means. Or for example, Brent, how tall are you? 6 foot. Patrick, how tall are you? Okay, good. All right. So, Patrick, I'm 5'8", 5'9". So Patrick is taller than me, right? Braden's taller than Patrick. So then how do I compare Braden? Braden is taller than me. That's kind of like how transitive works. So it's the transitive property, just yeah. Thank you. Courtney, probably about a few more minutes. Yeah. So okay, let's finish off these set of notes. We're gonna do one more proof, and we'll do the examples down below, and then we'll be done. And then I'll need to head off to the CLG, and I'll see you in there in about half hour. Okay, so same side interior angles. We talked about that already. So when this happens, they have to 180. So look at these two. We'll call it DCF, angle DCF, and angle CFG. Those who have to add to 180. We're on the same side. We already talked about that earlier. Those two add up to 180 degrees. When you have parallel lines. So the conjecture, if lines are parallel, same side interior angles are what we don't say they're congruent. Instead, we say what? What term do you use when you add to 180? Thank you, Emily. Supplementary, right? They're supplementary. So let's go through another proof. Let's do the algebra problems down below. And then I think then I'll go get the homework for you guys, and guys can start homework while Ms. Zurich is here with you guys. So, so the 214 notes, we'll hold off on that for Monday. It's all good. Okay, so let's prove this. So this is actually a better proof because they actually tell you what's given. They tell you what to prove. they told you that these two lines are the same. So the column, oh, that's the typo. This should be an N, not an L. So let's change that to an N. So K and N are parallel, I'm told that. You're asked to prove that 1 and 2 are supplementary. Okay. Well, usually when you write a proof, what you want to do is state the given information. So K parallel N. That's given. 3 points. Ultimately, we want to prove this, and I'm kind of cheating. I'll tell you there are 4 steps. I'd actually take a little more time with this, but I do need to get going soon. So angle 1, angle 2 are supplementary. We'll come up with the reason for that in a moment. What can you say about angles 2 and 3? They are. Yes, they have to 180. Correct. So we could say angle 2 plus angle 3, or the measure of angle 2 plus the measure of angle 3, add 180 degrees. So what reason could I say about that? When they're right next to each other, what do we call that? We form a straight angle. Yeah, you could say a straight angle pair, or we'll say a linear pair. Add the 180. Linear pair of angles. And I do have the geo honors teacher here, so I gotta be very careful with how I say things. Okay. Add the 180. That's true. Now we said this earlier. Now we know this. So we take what we've already learned and we build on top of it. 1 and 3. Remember, they're like inside the sandwich, right? They're opposite sides. What do we call that? When they're inside and opposite sides? Let's hear it. And what's true about them for parallel lines? Are they equal or are they supplementary? They're equal, yes. So we're going to say angle 1 is congruent to angle 3. And that's because alternate interior angles are congruent for parallel lines. Very important. You got to say parallel lines are congruent. Because you could have 2 lines that are not parallel. They're still alternate interior, but they won't be the same. Not as parallel. Has to be parallel. And then lastly, if you think about it, if 1 and 3 are the same, I could just replace angle 3 with angle 1. Right? I can just replace that. And if I do, then angle 1 plus angle 2 will be 180. So actually, I should probably add a 5th step here. The more I think about it now. So make a little correction there. So I could substitute, replace angle 3 with angle 1. So the measure of angle 2 plus the measure of angle 1 must also be 180. And I really should be using my iPad. So sorry, the handwriting is really messy. Not charged because I was doing this other stuff yesterday afternoon, as you guys know. Anyway, substitution. We call it the substitution property of equality because we're substituting. Called substitution property for short. And then lastly, angle and angle 2 are supplementary. And we call that definition of supplementary angles because clearly when 2 angles out to 180, they are supplementary. So now I can make that statement. Angle 1 and angle 2 are supplementary. So we'll be doing a lot of this throughout the year. This is called a formal proof. It's a logical flow. With that said, I'm going to actually set this up for you guys, and Ms. York will help you guys out. And I'm going to also give you the homework. So you guys are going to work on these last 2 problems. If you just think about what's happening here, the last diagram, what kind of categorization we use for those angles there? They're outside and they're opposite. Well, not quite. They will be vertical eventually, right? You can move the 5x here and it will be vertical to that. You could do that totally. But that's going to be alternate exterior angles. And what's the relationship for all exterior angles? They're congruent. So you're going to totally set up an equation where those two are equal to each other. If those two are equal to each other, what kind of skill are you going to use to solve that? If 5x equals x squared minus 6, how do I solve that? By what method? Factor, yeah, or quad form if you want, but factoring could work. Now this here, these are both inside, and also these are both inside. They have their own set of parallel lines. And they're on the same side. What's the relationship there? They're from the same side interior angles. So they add the 180. So you're gonna make two equations, and it's gonna be a system of equations you're gonna solve. So this is what we're talking about, the algebraic geometric connection, right? Which we really want to get stronger with, right? Especially after our last test, we want to get really better at that. So you're gonna solve these. I'll freeze my screen so at least you have this up. Work them out in your table groups. Ms. York will come help you guys out. Once you're done with that, you can start the homework. I'm gonna pick up the homework sheets from the copy room. I'll be right back in a minute. I'm gonna come and collect your tests also because you can't take them home this weekend. So yeah, so work on those in your table groups. Ms. York will come around and help you guys out. I do need to collect the tests from you guys, and I'll come around and pick up all of your tests. Yeah.
Oh.
I think it's the right statement. Solve for the
I have no idea yet.
I
I
know
got a
so.
bunch of them.
Sure, yeah.
There's some paper in the back.
Sure, yeah.
Thanks, Gordon. Appreciate it. That's present. Please turn this off.